Okay. Numbers with exponents are called exponential expressions, or powers, and they can be multiplied, divided, or raised to powers. Here are some rules. So here's the multiplying rule. So if I had two exponents with the same base, and one of them was raised, let's say, to the 2 power, and one's raised to the 6th power. What this is like is 2 5s. And this is like 6 5s. 1, 2, 3, 4, 5, 6. And so they're all multiplied together. How many total are there? There.
There's going to be 8.
There are. And so this is the same as 5 to the 8th power. There's a relationship between these two and that one right there. Okay, and so the relationship between the 2 and the 6 and the 8 is what?
8. Oh, well, I guess you already said 8. So that they're all exponents, right?
Mm-hmm. But what could I do to the 2 and the 6 to equal 8?
Multiply them. Well, add them, actually.
So if I took my 2 plus my 6, I'd get 8. And so that's exactly what the rule for the multiplying is. If you have the same bases, and they're raised to powers, you add the powers to get your answer.
Okay, got it.
So if we're dividing, let's say I had 8 to the 4th, and I'm dividing 8 to the 3rd, okay? And so dividing, if you remember, is like a fraction. And so this would be the same as having 4 8s. 1, 2, 3, 4 on the top, and 3 on the bottom. 1, 2, 3.
So it'd be like when you multiply, you have the multiply sign, then you add, and when you have the divide side, you subtract.
Exactly, because these are going to reduce out, and I'm going to only have 8 to the 1 there. And so this would be the same as 8 to the 1. So this 4 and this 3, if I subtracted them, I would get the 1.
So couldn't I just write 8?
You could just write plain old 8, since we don't need to write the 1 as exponent. Very good. So if I'm raising to the power, so if I had like 3 to the 4th power and 3 to the 3rd power, this would be like this. This means I have 3 of those, okay? So I have 3 to the 4th, and 3 to the 4th, and 3 to the 4th. You with me so far? Mm-hmm. This means I have 4 3s. 1, 2,
oh dear.
3, 4. No, I have 4 3s. 1, 2, 3, 4. And this means I have 1, 2, 3, 4. And I'm multiplying them all together. How many do I have total?
4 and 4 is 8. 12.
Yes. And so, what's the relationship between that 4 and the 3 to get the 12?
You multiply them.
You multiply them, exactly. So this is 3 to the 12. So if I'm let's go back here. So if I'm multiplying,
you add.
You add the exponents. If you're dividing, what do you do to the exponents?
You subtract.
And if you're raising them to the power,
you multiply.
You multiply. Okay, so let's do some examples. And letters work the same way. So it wouldn't matter if I put in numbers or letters in there. They would have the same rules. So let's do some examples. And they do some here. So let's do 7 to the 3rd divided by 7 to the 3rd. Ooh, that's tricky. What does that turn out to be?
7 to the... Oh, is it the recording?
Go ahead.
Oh, okay. So you would subtract them, so it'd just be 7.
7 to the what?
0?
0. Oh no, what's that mean? Right. What in the world does 0 mean? So let's check that out. I have 3 7s, right? Mm-hmm. And I have 3 7s.
Then they all just cancel out.
Also, what does that leave you with?
Just 0. Well, but there's a 7 still. But, I mean, what would you even do for that? Because there's nothing there.
What if... I have the same thing on the top and bottom, right? Okay? That's like having a number, let's say 12, divided by 12, right? What is 12 divided by 12?
0. 1.
1. What's 6 divided by 6?
1.
1. So back here...
So it'd just be 1.
So it'd be 1. So anything to the 0 power is 1.
Okay.
Okay.
I got it.
Okay. So if we had 15 to the 0 power...
It'd be 1.
Very good. If I had x to the 0 power,
It'd be 1.
anything, that's exactly right. So the 0 power is 1. Okay?
Got it.
So what if I had a negative value to the 0 power?
It'd be 1.
Very good.
Why would it be negative 1 though?
Would it be negative 1? Good question. That would mean
No, because it's an even number, right? Because wouldn't they cancel out if I had it?
Well, yeah, because I guess 0 is, in a sense, an even number, so that makes it positive, like we did with the squares and the fourths. But it also means negative 8 divided by negative 8.
Oh,
right?
and that'd be positive.
And that would be positive, okay? All right, and so if we did,
Don't forget about your cobbler.
yes, let's do that now. So if we did 4 to the 5th power and 4 to the 3rd power, that would be 4 to the
8th power.
4 to the 8th power. Right now I'm looking at the instructions in your booklet and it says that leave them in exponential form. They don't want you to put that in a calculator and figure out what 4 to the 8th is.
Okay.
They actually want you to know that you're going to add those together to get the 8.
So right now I'm not going to be doing any of that.
Right. So far I'm seeing it says leave in exponential form, so you're going to just leave it like that.
Okay.
Okay. And if you had 6 to the 8th and we're dividing it by 6 to the 3rd.
It'd be 6 to the 5th.
Yes. Now let's do something a little different. What if I had 6 to the 3rd divided by 6 to the 8th? I'm switching it around.
It'd be 6 to the negative 5th, right?
Yes, and now we need to talk about negative exponents. And so if we have negative exponents, what does that mean? Let's just work this out. This means 3 sixes here, and this means 8 sixes. 1, 2, 3, 4, 5, 6. Okay? These are going to reduce. I only had 6, 7, 8, sorry. Okay? How many do I have left?
You have 5.
5. And are they on the numerator or denominator?
Down the denominator.
They're down the denominator. So this is a 6 to the 5th, and there's an invisible 1 right up here.
Okay.
So when you have a negative exponent, you just put it downstairs and make it positive, and put a 1 on top.
Okay.
So let's do a couple like that. So if I just gave you y to the negative 3rd power, what do I do to make that a positive exponent?
You put y to the negative 3rd down under with a 1 on top.
Okay, so it'll be 1 over y to the positive 3rd.
Right, yeah.
Okay, positive 3rd. So let's do another one. And we'll do oh, what happens if it's already on the bottom? Like x to the negative 3rd. Now what do we do?
Do you do the reciprocal?
And you bring it up this time. So it's in the bottom, so to make it positive in the bottom, we bring it up, just make it x to the 3rd. If you wanted to put 1 on the bottom, it's technically right, but it's not, it's extra writing, so you can just do that.
Okay.
And let's do some like this one. 3 to the 3rd to the 4th. No, we already did that one. 6th.
Oh, okay. Hold on. I'm going to remember how to do this. You do... Okay, hold on. I remember. 6, 3 to the 3rd. So you do 3 to the 3rd, 3 to the 3rd, 3 to the 3rd, 3 to the 6 times. And then you have to do all of those 3 times. So you have the 3 to the 3rd 6 times, but 3 of them in the 6 times. So it'd be like 18 threes.
Right. So how would you have done that quick with that?
Oh, yeah. You multiply
Good
them.
job. 3 to the 18th. You just multiply them. So if we had 4 to the, or let's do it in variable. Let's do y to the 8th squared.
Okay, so then you do it y to the 16th.
Very good.
Okay.
And they're going to do, I see some on your homework here that looks like they have 2 different kinds of negatives. So if we had x to the 3rd and negative and 5 to the negative 4ths, I want no negatives. I don't want those anywhere. So how do I make them both positive?
Do you bring them both on top?
Well, this one's already on top right here.
So you bring the bottom one
For that
on
one,
top.
bring it down.
So you flip that one down and that
Yes,
one up.
very good. So this one comes down here and becomes x to the 3rd, and on top becomes 5 to the
4th.
Very good. Very good. And so I think we've done it all.
Whoa.
Fantastic. Okay, we're done.